The final thing we need to do to wrap up our quadrilateral reference sheet is to finish the back side of the paper and talk about ways of proving that a quadrilateral is a rectangle or a rhombus without actually using the formal definitions of it. And these are pretty simple things, so we're going to run through all three of them in just one fell swoop. I don't even know what fell swoop means. Isn't that embarrassing? I'm going to Google that as soon as I'm done recording this video. So, proving that a quadrilateral is a rectangle, we were told here the definition we're going with is that a rectangle is a parallelogram with 4 right angles. But that's actually a lot more information than we need. Let's say that we were given that this was a quadrilateral. I'm sorry, let's say that we were given that this was a parallelogram, but that it only had 1 right angle. Could we prove that that was a rectangle based on this, that the other 3 angles are also right angles? Well, yeah, we can, because what do we know about parallelograms? Parallelograms, the opposite angles are congruent and the consecutive angles are supplementary. So if this angle is a right angle, the opposite angle also has to be a right angle. And these angles here have to be supplementary to each other. So if one angle is 90 degrees and the sum of the two of them is 180, how big is the other one? Yeah, the other one is also 90 degrees. And once again, same thing is true for this angle down here. So we could also save ourselves a little time by saying all we need to do is to show that something is a parallelogram with just one right angle. All right. And by the same token, let's think of another way that we could make this a simpler thing. Let's say that we had a quadrilateral and we knew that it had 4 right angles, but we didn't know that this was a parallelogram. Could we conclude that this is a parallelogram just knowing that all 4 angles are right angles? Once again, let's go back to the first page of the reference sheet. So what it says down here at the very bottom is that if we know that we have a quadrilateral whose consecutive angles are supplementary, that's enough for us to know that it's a parallelogram. Are the consecutive angles in this quadrilateral definitely supplementary? Yeah, these two are supplementary because two 90-degree angles add up to 180 degrees. Same thing going on here. Same thing going on between these two consecutive angles. Same thing going on between these two consecutive angles. So that's just knowing that something is a quadrilateral with 4 right angles. That's enough information for us to know that that must be a parallelogram. And a parallelogram with 4 right angles is our definition of a rectangle. So we know that a rectangle is a parallelogram with 4 right angles, but actually we either need to know just that it has 4 right angles or that it's a parallelogram and it has at least 1 right angle. And that would be enough information for us to get to the end. Let's talk about the definition for a rhombus. So a rhombus, we're told, is a parallelogram with 4 consecutive sides. And that's true. But what if we knew that we had a parallelogram and that only 2 of its sides were congruent? Okay, is that enough information for us to conclude that this is a rhombus? Well, knowing that this is a parallelogram, we know that the opposite sides have to be congruent. So therefore, this side, because it's a parallelogram, has to be congruent to this side over here, and this side has to be congruent to this side over here. So if all we know is that something is a parallelogram, with 2 congruent sides, that's enough for us to conclude that it must be a rhombus, that all four sides have to be congruent. And just like we did for the rectangle, what happens if we don't know that it's a parallelogram, but we do know that all four sides are congruent? If we know that all four sides are congruent, can we conclude that this must be a parallelogram? Once again, yes. If we know that a quadrilateral has two pairs of congruent sides, that's enough for us to know that it's a parallelogram. So a quadrilateral with four congruent sides is enough information for us to conclude that it's a rhombus. And we didn't put down anything for how to prove that a quadrilateral is a square, but in that case, it's really easy. Since we know that a square is both a rhombus and a rectangle, in order to prove something is a square, you have to use one of the methods we know about to prove that it's a rectangle, and we also have to prove that it's a rhombus. And if we can do both of those things, we can conclude that it's a square. So that wraps up our quadrilateral reference sheet. We now know everything we need to know about parallelograms, rhombuses, rectangles, and squares to last us for the rest of the year.